Teaching a base model to actually follow instructions used to mean collecting huge piles of human-written examples. That is slow, and it is expensive. So here is the clever move behind Self-Instruct from a paper by Wang and colleagues in 2022. You bootstrap the whole dataset from the model itself, starting with only a tiny handful of human tasks. This is the recipe behind Alpaca and a wave of early open instruction tune models, and today we walk through exactly how it works. At its core, this is one loop that keeps feeding itself. Follow it once, and the whole idea comes together. Everything begins with a small seed pool of tasks that real people wrote by hand. We're talking about a modest set, maybe a couple hundred examples, each showing an instruction paired with a good response. That tiny pool is the only human labeling the method really needs. Then the model generates new instructions in the same style as the seeds. You prompt it with a few existing tasks and ask for fresh ones, so it invents new things to do, questions to answer, and problems to solve, all on its own. For each brand new instruction, the model also writes out the input and the output. So it is not just inventing the task, it is producing a full worked example, the kind of instruction and answer pair you would normally have paid a human to create. Do that at scale, and a tiny seed set turns into thousands of labeled examples. Finally, a filtering step cleans everything up. It removes duplicates, near duplicates, and anything low quality or malformed. The survivors get added back into the pool, and the loop runs again, growing a large and diverse dataset from that tiny seed. To really see the shape of it, watch the dataset itself grow through the pipeline. Start on the left with a seed task pool, just a small collection of human-written instructions, the entire starting point for everything that follows. Everything downstream feeds back here. That pool feeds a generation stage. The model reads a few tasks and produces candidate instructions plus their inputs and outputs, turning a handful of examples into a stream of fresh, self-written training data. Those candidates flow into a filtering stage. Here, duplicates and low-quality or invalid examples get dropped, so that only genuinely new and usable tasks make it through to the next step, and the survivors loop right back into the pool. Each pass makes the collection larger and more varied, and later rounds draw on that richer pool to invent even more diverse tasks. After enough iterations, you fine-tune the base model on this self-generated data and its instruction-following jumps. Strip it all down, and 3 ideas carry the entire technique. First, it bootstraps from almost nothing. A few hundred seed tasks are enough to kick off a dataset with tens of thousands of examples, so the human labeling cost stays tiny. Second, the model writes its own training data. It invents the instructions, and it produces the answers, which is where most of the scale and diversity actually comes from. Third, you filter and then fine-tune. Quality control keeps the junk out, and ordinary fine-tuning on what remains turns a plain base model into one that follows instructions well. All right, for takeaways worth keeping. This method builds an instruction tuning dataset almost entirely from the model itself, starting from just a small seed pool of human-written tasks. The model generates new instructions and writes their inputs and outputs. Then a filtering step drops duplicates and low-quality examples. Then you fine-tune a base model on that self-generated data, which gives a large jump in instruction following, the trick behind Alpaca and many open models. Bootstrapping training data from a model is one of the most quietly influential ideas in OpenAI. If methods like this interest you, Standarity.com breaks down many more. Drop by,